Hello, everyone. Welcome. Thank you for joining us today for this Microsoft Reactor event. Before we begin, I'd like to quickly review two items, our code of conduct and our event guidelines. So our event guidelines, this session is being recorded. It will be available in about 24 to 48 hours on our Microsoft Reactor YouTube channel. I'll be sharing the link to that channel momentarily in the chat. If you have questions, do feel free to drop them into the chat. We will most likely be answering those questions at the end of the session, but feel free as they come up to put them in there and we'll just search back and respond to them later on. If you have any other comments as well, feel free to drop those into the chat too. At the end, we'll most likely ask if you want to unmute. You can ask questions out loud as well. So our code of conduct, Microsoft Reactor seeks to provide a respectful environment for both our audience and our presenters. We ask for you to be mindful with your commentary, remaining professional and on topic, but we do encourage that engagement. So today, Microsoft is proud to bring you a workshop in partnership with ChickTech, a nonprofit organization empowering people of marginalized genders through tech programs and events. This event is open to everyone, and we're so excited you're here to join us. So today's topic is an introduction to Microsoft Azure Cognitive Services and knowledge mining, presented by Devanshi Thakar. Devanshi is a cloud solutions architect at Microsoft, focusing on AI and analytics technology. So at this time, I would like to bring Devanshi up.
Awesome. Hi, everyone. Let me share my screen.
Welcome, welcome. Glad to have you here.
Awesome. Well, while we're waiting for my screen to show up, in the chat, I'd like all of you to say a 1 if you've heard of Microsoft Azure's Cognitive Services, and a 2 if you've experimented with them, just so we can get a feeling of how many people have worked with it. That's awesome. Okay, I see a couple of 1s. Okay, well, cool. So as you guys are putting in those responses, today we're going to go through the entire collection of cognitive services and then a walkthrough of knowledge mining with these cognitive services. But first, let's start with a common problem in AI and ML, and that is needing a lot of training data, time to label it, time to train and retrain the data, deploy your model, and keep up with best practices. Expert talent is a primary limitation. I mean, individuals spent years researching different algorithms, and methods are often discussed ad nauseum before they are released for public application and consumption. But what if I told you that you didn't need to have a PhD to have cutting-edge research of AI at your fingertips? What if I told you that you can run state-of-the-art models anywhere within minutes in a pay-as-you-go model? All of this sounded very difficult to do before the emergence of the cloud. Microsoft dreamed of the possibilities to create several solutions to solve this problem and democratize AI. So that is where our cognitive services come in. These are a suite of services and products that leverage Microsoft research to create APIs that are accessible and easy to implement because of their simple REST API calls. So there's a common way to implement, and you can get started with all of them for free by simply going to one place, microsoft.com/cognitive. And so we've got a breadth of intelligence and knowledge APIs so that developers will be able to find what intelligence feature they need. And more importantly, they work on whatever language, framework, or platform developers choose. So you can integrate these into your apps, whether it's iOS, Android, Windows, using your own tools. And the nice thing is that no ML experience is required. These are high quality AI models, so you don't need to be an ML expert. And they're pre-trained as well as customizable models for you to use. You can run these anywhere, whether it's in the cloud or on the edge in containers. And in addition to our unmatched security, we also keep an ethical approach to AI in mind. So there's a lot of principles for designing and deploying AI responsibly. So today I'm going to talk with you about the entire collection spanning vision, speech, language, decision, and open AI. And so for vision, from faces to feelings, it allows your apps to understand images and video. In speech, you can hear and speak to your users by filtering noise, identifying speakers, and understanding the intent of the conversation. In language, you can process text and learn how to recognize what users want. And in decision, you can deliver specific recommendations to enable informed and efficient decision making. And there's a new one that is in preview. It's called Open AI. So essentially, these are dynamic models to power your apps. The nice thing is that a lot of these are API based and pay as you go. So you can just plug them into your application and there's no training or testing required. You can get instant results. And we're going to go through a lot of these examples through the presentation. So this is an overview. I'm going to go into depth into each of these buckets of cognitive services. And so let's start off with vision. So vision is split between three different services. There's the computer vision API, which allows you to extract rich information from images to categorize and process your visual data, and machine learning moderation of images to help curate your services. And then there's the face API. So some of the potential use cases for this technology include facial login, photo tagging, and home monitoring. And then we also have the custom vision service. So this is an easy to use customizable web service that learns to recognize specific content and imagery, and it's powered by the state-of-the-art machine learning neural networks that become smarter with training. So you can train it to recognize whatever you choose, whether it's animals or objects or abstract symbols. And this can easily apply to retail environments for machine-assisted product identification or in digital space to automatically help sorting categories of pictures. The second branch is speech, and this is one of my favorites. So there is speech to text, speech recognition, speech translation, and text to speech. With speech to text, as the name says, you can quickly and accurately transcribe audio to text in more than about 100 languages and variants. And you can also customize these models to enhance accuracy for domain-specific technology. So this can be done with custom speech service. So let's say you have a police dictation scenario and you have specific domain language that you need to use. So you can use custom speech service, which is going to enable you to create customized language models and acoustic models that are tailored to your application and to your users. So by uploading speech or text data to this custom model that reflects your particular application and your users, you can create custom models that can be used in conjunction with Microsoft's existing state-of-the-art speech models. And then speaker recognition allows you to recognize a human's voice in audio streams. It comprises of two components, speaker verification and speaker identification. So speaker verification can automatically verify and authenticate users from their voice or speech. It's tightly related to authentication scenarios and is often associated with a passphrase. So hence we opt for text-dependent approach, which means speakers need to choose a specific passphrase to use during both enrollment and verification phrases. Speaker identification can automatically identify the person speaking in an audio file given a group of prospective speakers. The input audio is paired against the provided group of speakers, and in the case there is a match found, the speaker's identity is returned. So it's text independent, which means that there are no restrictions on what the speaker says during the enrollment and recognition phases. One of the use cases for this would be biometric authentication using voice. Then we have speech translation. So this allows you to translate audio from more than 30 languages and customize your translations for organization-specific terms. And then finally, there's text-to-speech. So this builds apps and services that speak naturally, choosing from more than 270 neural voices across many language and variants. And a new release that just came out was the synthetic voices, which essentially means I can take my voice and create synthetic data that sounds exactly the same, exactly identical. So it's kind of scary, but also very neat. Then there is the language service. So you're able to identify key terms, phrases, sentiments, and do entity recognition and linking and more. You can annotate, train, evaluate, and deploy customizable models in the Language Studio without any ML expertise. The translator supports a wide variety of use cases such as translation for call centers, multilingual conversation agents, or an app communication. And the Q&A maker allows you to build a knowledge base by adding unstructured documents or extracting questions and answers from your semi-structured content. You're able to get answers from the questions and answers in your knowledge base automatically. We have decision. So in this, there's anomaly detectors, which allow you to monitor and detect abnormalities in your time series data. You have things like the personalizer, which allows you to choose the best experience to show to your users and learning from their real-time behavior and risky content. And then finally, this one is still in private preview, but it allows you to apply large pre-trained models to your new use cases, fine-tune those models using your data, and detect and mitigate harmful use with built-in responsible AI controls and filters. So all of those were a bunch of the cognitive services, and I want to go through a couple of demos. That moves on. All right. So this is Azure Search. So we went through the list of cognitive services, and there is a whole lot. So we want to see them in action now. So we'll take a look at a separate cloud search service that integrates with these cognitive services that I just went over. So Azure Search is a search as a service solution, allowing developers to incorporate great search experiences into the web, mobile, and enterprise apps without managing any infrastructure or needing to become search experts. So these are some of the common scenarios for Azure Search. There's catalogs, online retail, user-generated content, social networks, and line of business apps. So the one that's most common that I see is within online retail and e-commerce. Most customers of e-commerce application sites will find products by using search first. The product catalog is what is indexed, sometimes expanded to include tags, descriptions, feedback from users, etc. So this scenario is categorized by fine-tuned ranking models that take into account aspects such as star rating, price margin, and promotions. The search experience often includes faceted navigation, filters, and various sorting options. Frequent updates are also common. So while the product catalog does not change that often, there are things like product prices, stock levels, and whether items are on sale that can change many times during the day, and that needs to surface quickly within these search results. Another scenario is user-generated social content. So there are many different flavors of user-generated content applications, but most share similar requirements when it comes to search. Examples of these kinds of applications include recipe sites, photo sharing sites, user-contributed news sites, and social network applications that have a web and mobile presence. These applications deal with a large volume of documents, sometimes even millions, particularly when they allow users to comment and discuss on the items. So geospatial data is often involved relating to location of people or things. And the relevance tends to be driven by text statistics in addition to domain-specific aspects such as document freshness and author popularity. And then finally, we have business applications. So the users of line of business applications often navigate through their content using predefined menus and other structured access paths. However, when search is incorporated into these applications, there's a lot of friction that can be removed from general user interaction, making it quicker and more efficient to retrieve this information. And so this type of application typically has many different types of entities that need to be searched together, providing a single entry point to discover content through the system. In all these scenarios, the endpoints tend to be a mix of mobile devices as well as websites. And most modern applications either have both or simply blur the lines between them. So Azure Cognitive Search can be used to directly help clients and support either type of these applications. Okay, so let's get into the meat of how cognitive search really works. This is essentially an AI-first approach to content understanding, and cognitive search is powered by Azure Search, if you all may have heard of it before, and with built-in cognitive services. So it's going to pull in data from a variety of Azure data sources and applies a set of composable cognitive skills, which extract knowledge. And this knowledge is then organized and stored in a search index, enabling new experiences for exploring the data. So at a high level, what we want to do is ingest the information, enrich it using cognitive services that we've seen before to generate certain annotations. And these annotations are going to later help us search the information. So you can connect to a variety of data sources and be able to understand each of the different file formats. This stage is called document cracking. So let's say you have a PowerPoint, right? The first thing you want to do is understand the format. Are there images in it? Is it just text? Are there diagrams? And once that content is extracted out of those files, then you want to enrich them using a skill set. So a skill set is going to be a set of skills. So you can have cognitive skills, machine learning algorithms to enrich the information. And this helps generate an annotated document, which is a tree of information that we can then map into a searchable index. So a little bit more on document cracking. You want to be able to read information from many sources. So Azure Cognitive Search supports structured data. So this is going to be things like a natural SQL database or Cosmos DB, and also unstructured databases. So this is going to be Azure Files or blob storage. And then you want to get your data from these data sources and then understand the file format. So there's a variety of file formats that we'll see in the next few slides that Search supports. But of those, some include JSON documents, Word documents, PDFs, PowerPoints, all of that good stuff. And then once we understand that data, we can extract the text, the metadata, and the images out of these files so that we can further enrich that information. So to do that, there's a variety of built-in skills. So these were the ones that I was talking about before with cognitive services. So there's sentiment analysis, entity detection, language detection. But we have an extensible system, which means that we can support custom skills as well. So if there are skills that you want to write out, so if you want to bring your own algorithm, your own code, your own ML model, or regular code, you can plug that in as a part of your whole skill sector enrichment pipeline. All you need to do is make a clear input-output interface. And then there's something called a sample skill set. So text and images are extracted from a document. And you want to take the images and extract the printed text out of the images with an OCR skill. And then we want to merge the text from the document itself with the image text. Once we have that, we want to identify entities like organizations or locations, maybe even celebrities if there are any. And you can define skill set programmatically or through the UI, so it's very convenient. Once you do this, you're going to create the annotated document that I was talking about, and then you need a mechanism to feed them into a searchable index. So we need to ingest these files. We crack open different types of files, enrich them with the skill set, map annotations and enrichments to a search index, and then we discuss how to select from a variety of built-in skills as well as custom skills. So a lot of information, I know. There's a lot of steps. We'll go through a demo in the end to make this a little bit more clear. So that is the overall architecture of cognitive search. Now let's go through a couple of different formats and data sources. So during the ingestion portion of when we're taking in a lot of data types, we want to support a variety of them, and then we want to ingest those different types into file formats as well. So we extract text, images, as well as metadata. So some of the formats, like I mentioned before, are PDFs, JSON documents, which I see a lot in a lot of businesses. There's PowerPoints, CSV files, and then we're able to pull them from a variety of sources as well. So for the purposes of today's demo, we'll look at Azure Blob Storage, which supports unstructured data. But there's also Cosmos DB, Azure Table, MySQL, things like that. And I think newly integrated is also SharePoint. So now we're ready for the next step, enrichment through our cognitive skills. And we have a bunch of built-in cognitive skills, and I won't go through them again. I know we spent a couple of minutes in the beginning of the session going through them. But from the extraction of entities or detecting faces, these are all skills that you can integrate into your enrichment pipeline. But you can also implement your own custom skills. And so this can be as simple or as complex as you want. For example, it could be an Azure function or an ML model that has taken a long time to build. So there's a lot of interesting capabilities that you can integrate within your enrichment pipeline. Awesome. So let's actually build out a cognitive search solution for business documents using our Azure platform. So knowledge mining is essentially unlocking valuable information lying latent in all your content in order to perform an action or make certain decisions. So Azure Cognitive Search helps us do that. So let's go into a little demo. I'm going to stop presenting and share my screen. Okay, so we're going to go into the portal as the first step. So there's a couple of prereqs we need to figure out when it comes to going through the search pipeline. First is going to be having a Azure subscription, which I'm in right now. Second is going to be creating a search service. And then third is going to be creating a storage account where you're going to store a lot of your data. And so I already have my Azure subscription. So the first step is going to be creating a search service. I've already made one, but for the purposes of the demo, let's go through the process. So we're going to create a Azure Search Service instance. And the first thing we want to do is link our Azure subscription over here. We're going to create a resource group. And so you can think of a resource group like a folder that essentially holds all of your files for a certain project. So I'm going to select create new, and we'll say demo resource group. There we go. Awesome. And then we have our service name. So we will say demo search service. And then location, I choose West US 2. You want to choose the location that's closest to you to avoid any latency issues. And then I'm going to hit review and create. So that'll take not too long to create a search service. And it'll show you this screen. So it essentially says deployment is in progress. Once it's done, you can hit go to resource. And this is going to be your search service. So this is where you're going to build your enrichment pipeline, figure out your indexes and indexers and data sources and all your skill sets. All of that stuff is going to be within here. But the second thing we want to do is upload all of our data into our storage account, right? But I want to show you guys what data we're going to be working with today. So I have downloaded about 11 of these files, and they're Spanish and French documents about museums that are located in Spain, and they're both in French and Spanish. And then there's, I think, 1 or 2 documents with images of certain museums. So what I want to do is extract, use computer vision to figure out what the image actually stands for, translate it into text, and then be able to search through that as well. So that's our data. We have 11 of these files that are in French and Spanish on different museums. And we're going to search and figure out information about these various museums. So that's the data. Now what I want to do is upload all of this data into my storage account. And we haven't created a storage account yet, so that's probably going to be our next step. All you do is search for storage accounts, and then you're going to hit create. And then, so I have my subscription right here. Again, you're going to choose your resource group. So that one was demo resource group. And then I'm going to give it a name. So and doesn't like the hyphens, so we'll take them away. Okay, there we go. What is it not like? Certain words. Okay. There we go. All right, and then once you have your storage name, you're going to select the same region as you selected your search service, and this is to avoid any bandwidth issues. So once you have that, you're going to select your performance. We're going to go with standard, and then you're going to hit review and create. So once you have that, that is going to be your storage account. So we are storing everything in our blob storage container. So the next step is going to be creating a container and uploading all of the files that we want to work with and that we want to be able to index through within that container. So let's give it just a second. Awesome. So go to resource, and then what I want to do is in the left, we have a containers column tab. So I want to click on that. I'm going to create container over here. Let's name this Spanish, French museums. All right. And then I have successfully created my storage container. So within this, what I want to do is upload all of the data that I want to index. So that's going to be all of these files. So as you guys can see, I'm using the UI right now, and it's very convenient, very easy to use and play around. Of course, you can also use the APIs and be more programmatic with this. So awesome. I have downloaded all of my files right here. And just to show you the one with the image, it looks something like this. So this is referencing the Dolly Museum, and I want to see if it's able to use computer vision to an OCR to figure out the text in this image and also return that as one of the results when I query. Cool. So we have our data. We've uploaded it to the blob container. Now what I want to do is go back to our search service. And over here, I want to, so this is the one that we're working with. I want to import our data to set up the cognitive service enrichment pipeline. And where do we start? So the first thing is going to be import data. So let's click here. We're going to import our data from our storage account that we just created into this enrichment pipeline, or this pipeline, sorry. And so first thing we want to do is hit Azure Blob Storage because that is our data source. We're going to give it a name, Spanish, French, Museum. And then we want to extract both the content as well as the metadata. And we are going to use a connection string. It usually just pops up, which is nice. And connect it to our blob container. And then finally, so the container name pops up and we have the option to add our cognitive skills. So this is the exciting part. Okay, so there's three things we can do. We can attach our cognitive services. And so for this demo, we've utilized the free resource just because there's not a lot of documents that we have. Then what we want to do is add enrichments. So essentially, we're creating a skill set where we want to enable OCR and merge all text into the merge content field. So the reason we do this is for image analysis, images are going to be split from the text during document cracking. And so the merge content field will reassociate with the text and images within the AI enrichment pipeline. So we want to put all of the image content from OCR as well as the text data from the document together in the merge content field. So we do that, and that's going to be our main source data field that we want to query. And now we have the options to select different things that we want to extract and put into and select our index essentially. So I want to extract people's names, organizations. Let's just do everything. Why not? Just to see how it looks like. And then I want to generate tags from images and generate captions from images. Awesome. And we will save that last part for later. So next. Okay, so this is where we are going to identify our index. So we've named it over here. I've given it a key. And so you can select different fields for your index. Essentially, retrievable means that you're able to, that it's going to show up in the results. And searchable means that you'll be able to search for them. So the ones that you've selected from before are automatically going to be retrievable and searchable, like the ones that we selected out here. The one that I want to create facetable is going to be language. So essentially here you're creating your index, which contains searchable content. So the import data wizard, when we imported our data, it was able to infer a schema for you by sampling the data. And so that's how it creates some of the fields over here. And we're able to give each of these some attributes. So again, searchable allows for full text searching of a field, and retrievable means that these field values can be returned in the results. So now we're going to create an indexer. And so the indexer is interesting. So we need some sort of entity that's going to be aware of the data source and changes that happen in the data source. So the indexer allows you to select the frequency. Let's say that within your data sources that there's been a change in the documents. And so this is going to allow you to schedule how often you want to be able to index your data and go through that process again. So for the purposes of this demo, we're just going to do once. But you could select hourly, daily, or custom. So awesome. So we've created our index in our indexer. Now it's going through this pipeline, setting it all up. So we can go through the monitoring stage where we'll able to see what's happening, and the index is being created as well as the indexer. So if I click here, it'll say no history right now, but then it'll say in progress. So let's wait for that. And actually, while that is happening, I have created a search service already. So we're able to see the indexes. Okay, there actually. So the other one has already been loaded. So there's 11 documents, which is right because that's the amount that I had uploaded. And the indexer will show success. So it'll show something like this when it's finished indexing through our documents. Let's go back. Okay, so there's 10 documents. So maybe there are only 10 that got uploaded. We have to go back and check that. But let us now go to the Search Explorer. And so this is where we're able to query different things based on the enrichment pipeline that we've created and the data that we've uploaded. So there is a query that I have already tried up in here. So I want to search for the Dolly Museum, and specifically that image, I want it to show up. So when you just do this, so when you just search for a certain keyword, it's going to give you everything that where that keyword exists, but also a whole bunch of different fields. And it's always a little bit hard to read through within this JSON output. So what we can do is specialize certain things. So out of the metadata storage name, key phrases, locations, translated text, and merge context, and image tags, those are the only things that I want to show up in the results. So I have specified that, and I'm going to hit select again. And there is an issue. Let's see. Okay, paste it one more time. All right, metadata storage name. Okay, so we'll take that one out and just do it with key phrases. Okay, so this is awesome because we can see a bunch of our, so the ones where the Dolly Museum was said in the text, so either within the locations or within key phrases, if we keep going down. So it has actually taken all of the French and Spanish documents and translated them into English, which is the language that we specified it to translate in. But this is really nice. We see the merge content. If there were any images in the document, then it has taken the text from those images and put it together with the text of the document itself. And it does that for every single document that matches. So it'll show you the locations, key phrases, all of the things that we've specified it to show. And then we can also see things like the search score, which is nice. So it just depends on what you all want to see. But I was hoping that it would show the name of the file so we could see it. data. We could actually go back. Okay, so this is the same one that I ran yesterday. Let's see if it works in here, because I want to show you all. Okay, so this is one that I ran yesterday. It's the same document, but essentially with that query, I was able to see what the name of the file was, where it found references to the Dolly Museum. And then it'll show me the translated text, merge content. So what was interesting was this picture that I showed you all here. I was able to point out that it matched in this file. It was able to translate the text, so get all of this text through OCR, and also give the image certain tags. So it says text, book, poster, newspaper, and human face were some of the keywords that it identified. And then in another file where it specifically was about the Dolly Museum, it picked out certain locations, certain key phrases. And then I believe in the last one, there was reference to a man whose last name was Dolly. And so that's why that one was picked out. So those are the three main files that matched with this query. And so that's how you can know a little bit more about the file. And obviously, we've done some cognitive services enrichments, but there's a lot more you can do with machine learning algorithms and whatnot. So that was a little demo of the cognitive search service. Let me go back and present. All right. Yeah, so in summary, we kind of went through all of our cognitive services as well as the cognitive search service. And so that was the main demo. And that kind of concludes my presentation here. But I would love to call out to action. I know Rebecca has been posting a bunch of helpful links in the chat. But we have a link to our Microsoft Azure developer community, and that's where you will be able to find a link to the presentation deck, as well as some of the Learn module resources. So if you're interested in cognitive search and learning more, you can click on those and experiment over there. And then that would be it. Thank you all so much for being here and for listening to the talk. And now I can answer any questions that all of you have. And Rebecca, if you have any final comments.
Sorry, just unmuting myself here. So we did have a couple of questions early out in the start of your presentation, which you may have answered, but one person asked, what are the trade-offs or pros and cons when using a pre-built service like Cognitive versus building in-house models?
Awesome. Yeah, great question. So I would say that if you're someone who's new to learning cognitive services, then using the pre-built services are the best way to get started because it's a very low-code approach. And so there's a bunch of different pillars, right? There's 5 that I went through. So you go through those pre-built services to see what's available. Then if you need specific customizations, for example, in the speech services, if you have specific domain language that needs to be recognized and the speech to text pre-built service is not picking it up, then that would be the way to go, is then use a custom speech to text model that you yourself can train and retrain based on your data.
Awesome. And then we also had the question was a bit vague. So perhaps, Kojaki, you're still on the session with us. They had asked just OpenAI in Azure, question mark. So that was on the earlier part of your, oh, when.
Yeah.
They added a when. Okay.
Yeah, if you want to expand on that question, please feel free to come off of mute. But that's essentially a newer service that has just came out, and it's a part of the cognitive services now. There's OpenAI and GPT-3 models that are part of that service. And so there's some really cool things that you can do. There's some code creation features that are new as well. So that would be something that I would encourage you all to check out.
Awesome. Follow-up question. When did you OpenAI become available in Azure?
That is a good question. I would have to check. I believe it wasn't, it was a couple of months ago. But it's, if you just go to, if you just type in cognitive services, Microsoft Azure, it should show up as one of the pillars, and you should be able to play around with that.
Awesome. Fantastic. So I'm not seeing, I don't know if Teams did an update since the last time I've run a Teams session, but I'm not seeing my presentation. Do you guys see it? The Q&A slide?
I see it, yes.
Okay, perfect. So a couple more questions are coming in.
Awesome.
Kojaki followed up asking, is this still in a beta
Yes.
scenario? Okay.
It's still beta, still private preview. So I believe initially you can gain access to play around with it, but there is a form that you need to fill out.
Okay. Next question. Can you run different models on the same data source?
Yes,
Like
you
image
can.
search, speech to text, same data.
Same data on, can you repeat that one more time? Sorry.
So they were asking, can you run different models on the same data source, like image search, speech to text, all on the same data? Can you do different models at the same time?
Yeah, so if this is in reference to Azure Search, then yeah, you can, based on whatever data source you have, you can use any cognitive skills to enrich your pipeline. And so that would be on the same set of files that you've started working with.
Awesome. Anybody else out there, if you have questions, again, feel free to drop them into the chat. We have a few more minutes here. You can also unmute yourself if you prefer. While we give the audience a couple more seconds to think it over, process everything, I'm just going to quickly do a little Reactor plug as well. We got a thank you from one of our audience members as well. Thank you. Yeah, this was fantastic. So sorry, I'm like so focused on like getting through the
All
whole
good.
process, but this was fantastic. I think you really covered so much information. We had a wonderful turnout. People, stayed on for the entire time, so that's, always a great it was a great sign to show that the content's awesome. To the chat, I dropped the link where you can find both the slide deck, which we'll make available probably in the next day or two, so it might not be loaded up there yet, but it should be soon. Additionally, there'll be free learn modules. So Microsoft offers a lot of free learning. If you're not familiar, if you go to Microsoft Learn, you can find and search for things of your interest that you want to learn more about, both beginner, intermediate, and expert levels of learning. And then if you have the opportunity, if you feel like doing it, we have a survey. We just ask the audience a little bit about yourself so we know, like, for future curating of content for the Reactor, just who our audience is, what you want to see based on your background. And then if you are tuning in for the first time, if someone else told you about this session, this is part of a partnership between Microsoft Reactor, Chick Tech. But if you are interested in getting more sessions, we are always updating our calendar. You can find us on meetup.com. We have 12 physical spaces around the world, so find the time that works for you and the location that works for you and check out our virtual sessions. I think at this time, it looks like lots of thank yous and appreciation in the chat. Thank you all, audience. We appreciate your feedback. I think we might call it a wrap.
Awesome. Well, thank you all for being here. Thank you, Rebecca. Thank you, Rennie, for setting this all together. And I would encourage all of you to try out the cognitive services. Like I said, a lot of them are APIs, and there's some great documentation out there. So whatever section, pillar you're interested in, go ahead and check it out. And obviously, Rebecca has put out those resources, so you can check out those after as well. So thank you, everyone.
Thanks, everybody. Have a good
Awesome.
rest of your days.
All right. Bye.